All right, so today I'm going to do a review of what to expect for test number 3, which is this Wednesday. Should also know that the final exam is a week from Wednesday, from 2:45 to 4:45. I believe that's the time, but I will, of course, send you an email to confirm that. Final exam will have 2 parts. We'll have the core part, which I've decided that you'll enter your answers into Canvas, into a separate Canvas test, or it'll be like an essay format type of thing where you can just type in your answers. I do plan to record a short video on Friday, sometimes Friday, which will explain how to use Canvas for that first part of the course, such as how to enter symbols and things like that. All right, so that's something I will do. All right. Now for the test, now we have a quiz today, of course. The quiz will cover hypothesis tests, stack key hypothesis test, plus there's a final question, 5th question on today's quiz, which will be not fill in the blank or true false. It's sort of a matching question. So there will be a phrase, 4 phrases. Each phrase will have a drop-down box. You just pick the closest item that relates to it. All right, so we'll try that out, see how that works. Now, for the test, there are 4 complete chapters that we will cover in the test that we've already covered. And that includes chapters 14, 16, 17, and 19. So those are complete chapters in the book. Let's see something here. James is asking, is our lowest quiz going to be dropped? I'm not sure yet. Remember, there are 9 quizzes, so it was like 4 or 5 quizzes. Good chance I would drop the lowest one, but 9 quizzes, not quite sure whether the lowest one's going to make too much of a difference in your average by dropping it. So the answer is not sure. I want to give away the store right now, but given I'm having 9 quizzes, I'd say more likely not than more likely I would. All right, so hopefully I answered your question. Now, the stat key, of course, will be on the test, obviously on the quiz today. We'll cover both confidence intervals and hypothesis tests. What I'm thinking of doing for the hypothesis test and for confidence intervals, there are 4 types. There are the individual mean, individual proportion, difference in means, difference in proportions, both for both hypothesis tests and confidence intervals. So there is a chance I might create a chart for each one of those and just ask some questions. The way I think I'm going to format the questions for those particular questions, just for those, is to give you 2 statements about the chart. They'll either be true or not true, and then the answer key will be basically both of them are true, both of them are false, or maybe the first one is true and the second one's false, so the second one is true, first one is false. So those would be the 4 options for the stat key, the ones that I actually give you a chart, stat key chart, and then you decide whether those statements are true or false based on what you're looking at. And then everything else on the test will be just the way that they've been presented in the past tests, pretty much like that. Now, I mentioned those 4 chapters, 14, 16, 17, and 19. For the stat key, there are certain sections that I want to emphasize somewhat, because the fact is this book that you have is not written to do stat key. That's pretty clear. There's nothing about stat key in this book. So it's a little difficult to give you something from the textbook that supports it. That's why I provided that video before Thanksgiving, the Wednesday before Thanksgiving, which was an introduction to hypothesis testing. I wanted you to really hear that. If you haven't heard it, you should hear it, because otherwise hypothesis testing is a little confusing. So please do listen to that if you haven't already. And then, of course, the other videos for the other classes where I've gone through sample questions, samples of how to use StatKey. Would be very important for you to pay attention to those. However, the textbook does have a couple sections which may be helpful. It's the only way I could say it. In chapter 20, sections 1 and 2, section 1 and section 2 in chapter 20. Chapter 22, sections 1, 2, and 4. I did ask you, I sent you an email and asked you to read a few pages, which was section 4, chapter 22. May be helpful for this quiz. Maybe, well, I would say definitely helpful for this quiz, and maybe helpful for the test to review those sections, all right? But unfortunately, this book has formulas for. Oh, I'm sorry, go ahead. Who's talking? Tamir? Yes. Your question?
Yeah, I said, can you repeat it, please? Can you repeat what you said?
What about the sections?
Yeah, you say 463 to 468, right? Or no?
Oh, you mean those pages that I mentioned in the email?
Yeah.
It was 483, 86. That's section 4 of chapter 22. So that's part of the reading that I would recommend that you look at. Not only for today, but for Wednesday. It will play a part in today's quiz too, I'm telling you that. So hopefully you've read it. If you haven't read it already, I would sit down and read it now, while you're listening to me. All right. So chapter 14 is probability. This is a chapter where you may have some probability calculations possibly to do. Chapter 14 talked, and really it's very basic. It's nothing heavy duty, no heavy duty probability in chapter 14. But they do make a distinction between what's called the long run relative frequency approach, probability. That is to run an experiment over and over again and come up with a relative frequency, which is an estimate of probability of an event. Also, personal probability is mentioned in here too. That obviously what makes sense to mention that, because most people in life develop their personal probabilities not based on any experiments. So that's just described a little bit. But there are these 4 probability rules that in chapter 14 that I would pay attention to. The first rule is that if you have 2 possible outcomes of a probability experiment, that the sum of their probabilities are equal to 1. The second rule says that if 2 outcomes cannot occur at the same time, such as when you roll a die, you can't get both a 2 and a 3 when you roll it once. Those 2 outcomes are called mutually exclusive. So you say, what's the probability of getting one or the other outcome? You would simply add their probabilities. Rule 3 states that if 2 events do not influence one another, that is, the knowledge of one event does not influence or change the probability of the other event, then the 2 events are considered to be independent of one another. And therefore, when we say what's the probability of event A and event B occurring at the same time, we would use the multiplication rule and multiply their probabilities. And then finally, rule 4 talks about if you have a subset, if one event is a subset of another event, then the probability of the subset has to be less than or equal to the probability of the bigger event. All right. So I could ask any type of fairly straightforward probability question using those 4 rules, maybe a combination of a couple of them. Towards the end of the chapter, I would pay attention to the what they call long-term gains or expected gains, things like that, where you multiply the gain times the probability and add them up, and you come up with an expected gain. We went through examples of that in class. That certainly could be a possibility for the test. All right. Chapter 16, now we're skipping 15, even though the syllabus does talk about chapter 15, by the way, it mentions it. To me, it's more optional reading because it gives you a background on simulation, which is what StatKey uses. But I'm not going to ask any specific questions from chapter 15, nor will I ask any questions from chapter 13 either. Although it gives a background about significance testing, hypothesis testing, it's really about relationships between 2 variables, and that's not something that is covered in this course. So I'm not going to cover that, but it is more background reading. So chapter 16 is the next one. And chapter 16 are those psychological elements that may affect personal probability. All right. So these different types of effects that are talked about, such as the certainty effect and what else? Availability, heuristic. Remember what a heuristic is? It's some sort of simple cognitive procedure that helps us come up with answers to questions. So the availability heuristic, anchoring, all of these things that we've talked about before, representativeness heuristic, overconfidence, optimism, any of these things that are mentioned in that chapter, I could ask a question about. Questions about. All right, so that's more of a, that chapter is more of a concept or definition type of chapter. Chapter 17 is about how intuition differs from relative frequency. Mentions the concept of coincidence. Talks about that birthday rule, a probability if you have so many people in a group, what's the probability of at least 2 of them having the same birthday? That's mentioned in this chapter. There's the thing called the gambler's fallacy. All right, gambler's fallacy. Gamblers tend to believe in the law of small numbers, not the law of large numbers. The law of large numbers is what insurance companies use and casinos use to come up with correct probabilities. But gamblers, being a little short-sighted, might use what they think is the law of small numbers. They think with smaller samples, they can come up with the same results as larger samples. And that doesn't always work. So that's mentioned also in chapter 17. So that might be something that I could ask about. And also they talk about the probability of false positives. Now, if you did read chapter 22, section 4, which I suggested that you would read, they do talk about false positives and false negatives in there. So you need to know the definitions of those. They also talk about the sensitivity of the test and the specificity of the test. Mentioned on page 373, know those definitions. Could definitely ask you questions about that. Now remember, you don't have to memorize any of this, right? You just look it up in the book. You have the book is available to you. Your notes are available. Anything that I put out on Canvas, any PDFs that I put out on Canvas, you can print out and have that by your side too. You know, have a working calculator so you can do calculation questions. You can use Excel if you want. You can use Google Sheets if you want. You just can't have somebody helping you. All right, so you have to be working independently. So I'm just pointing out certain things that I can ask on the test, all right? So these types of definitions, probability of false and positive, sensitivity, specificity of the test, are definitely ones that I could ask about, all right? So that's chapter 17. Not a whole lot there, but there's enough where I can ask a couple of questions here. Nothing for chapter 18, but chapter 19 is an important chapter because it deals with basic ideas of sampling and coming up with what are called frequency distributions of all possible samples. And so this is an important chapter. It sort of lays the groundwork for confidence intervals and hypothesis tests. So you definitely want to know something about, like on page 411, what are the conditions for which the rule for sample proportions apply. All right, there's 3 conditions mentioned there. And then defining the rule for sample proportions is on page 412. One thing that you do want to know, even though it's not used too much else in the course, is how to calculate the standard deviation of a frequency distribution for proportions. On page 412, and it's the square root of the true proportion times 1 minus the true proportion divided by the sample size, the square root of that entire thing. And it gives you an example in the book on page 412, how to calculate it. And then on the next page, 413, it talks about this rule about if you have a bell-shaped curve, that 68% of the probability is between the sample mean plus or minus between the mean, I guess in this case it would be the population mean, plus or minus 1 standard deviation. That is, you subtract the value of 1 standard deviation from the mean. That'll be the lower end of that interval, and then add 1 standard deviation, value of 1 standard deviation to the mean, and that would be the right end of the interval. And then we would say there's a 68% chance that the sample proportion is between those 2 values. All right, 95% chance that it's between plus or minus 2 standard deviations. And then it says almost certain. What they mean by that is 99.7% chance that it's between plus or minus 3 standard deviations from the mean. All right, so again, that's on page 413. Simple calculation to do, but it's right there. And I could certainly ask you something about that from this chapter. On page 415 is a rule for sample means. Involves either 2 situations. They mention what the 2 situations are. So that's something you may want to look at also, page 415. And then the rule for sample means is on page 416. In this case, the standard deviation that you use is for sample means is the population standard deviation divided by the square root of the size of the sample. It gives an example right there on page 416 of how to calculate that. Then on 417 and 418 gives a brief introduction, brief definition of what a confidence interval is and what a hypothesis test is on page 417 and 418. Okay, so that's that. All right, so that's sort of the chapter 19 introduction to what's going to happen with StatKey. Use StatKey to do what are called confidence intervals, which are estimates of the population mean or population proportion, or the difference in means or difference in proportions. So in the test, as I mentioned, very high chance that I'll print out one of those confidence intervals, those bootstrap confidence intervals, and I'll ask you questions about it, just like not this quiz, but the quiz before. I could ask you some questions, give you maybe 2 statements and ask the truthfulness of them. whether both are true, both are false, one is true, the other is false, that sort of thing. Okay. So just review how we normally do confidence intervals. I believe confidence intervals are easier to understand than hypothesis tests for most new students. So I think you all should do well on the confidence intervals part of it. Now, on chapter 20, sections 1 and 2 is where they have a little bit of information about confidence intervals. But I can tell you that if there's any formulas that are being used in those two sections, we are not using those formulas. We're using the bootstrap method of creating confidence intervals, all right, that are used in Stackey. Then hypothesis tests. I strongly recommend, and maybe you didn't do it for today's quiz, and don't worry about today's quiz so much, because if you don't do well, there's 8 other quizzes that you took during the semester, and so one quiz is not going to ruin your quiz grade, but or overall grade. But people tend to do not as well on the hypothesis tests. So if I were you, I would go back to that video that I recorded again, mention it again, on the Wednesday before Thanksgiving. It is an introduction to what hypothesis testing is. It gives you the theoretical understanding of it, and then I believe the after Thanksgiving, the Monday after Thanksgiving is when I went over the idea of p-values and started showing you how to use Stackey in hypothesis tests. I printed out 2 PDFs. I created 2 PDFs on hypothesis testing. One is just an introduction to show you how it works, and then the other one talks about the steps of the hypothesis test. But I would spend some time on that for sure, because again, my experience with hypothesis tests is that most students, very rare student who does really well in hypothesis tests the first time they see it. Most students have struggled with it, all right, and it's not uncommon. So don't think there's something wrong with the way you're understanding it. It's pretty prevalent, all right. Again, I recommend watching those videos on it again. And then even in Stackey itself are those videos that explain how to do hypothesis tests, the randomization hypothesis test. It's only 20 minutes long. Watch it, watch that again. It will help you understand it better. Now, today you may say, oh, I didn't do well in the quiz. Don't worry about it. You still have until Wednesday to do all of that preparation. And then you'll understand more about how Stackey works, all right? But definitely, when I showed you the steps in class, it's important to go over those steps again. If you don't, you're going to be struggling, most likely struggling with the questions. And that's unfortunate, because if just with some review, I think you could do well on it. All right, so let's see what the time is. Now, we still have about 12 minutes. Anybody have any questions about the test? Okay. Let me just show you something, see if I still have these open. Let's see. I do.
Do you have a curve test grades?
Do I have a curve?
Do you ever curve?
I give it extra credit. Don't you think that's a curve, isn't it? Wouldn't you agree that's a curve?
What's extra credit?
Well, let me rephrase that. Let me rephrase that. A curve means that you take everybody's grades and you scale them, right? You scale them. But curves only work if most people do things at a certain level. So I don't think curve is necessary here, because number one, I'm give extra credit. Number two, my grades are lower for an equivalent grade that some other professor gives. In other words, some other professor says you pass with a 60, and in my course, I believe it's a 52. Some other professor will say you need a 93 average for an A, and mine's a 90. So with the extra credit plus with each of those 3 tests, plus the lower grade scale, I believe that's a curve. Don't you agree? It's a curve without actually, without me actually determining whether I need a curve or not. I'm giving you a curve up front. So I hope you do appreciate that I'm doing that. All right, does that answer your question, I hope?
Sure.
Did you say a passing grade was a 52?
Yeah. Yeah, I believe it is. I think you start off at a 90 and you just keep subtracting 4 until you, I believe you get to a D minus is a 52. You could check the syllabus, but I believe that's what I originally created. So that's better than others professors. So I'm giving you quite a bit up front. All right. So let me just show you, let me share a screen here with you, and let me see if I have these photos. See if this is a hypothesis test here. Hold on one second. I want to make sure I'm giving you the right one. Yeah, I'll give you this one here. Hold on one second. Let me see if I can share this with you. I believe this is one that I think I might have shown this in class, this one here. Let's just take a couple minutes to review what this is, what you're looking at, all right? Because I want to make sure that you have some basic understanding of a hypothesis test. This right here is the null hypothesis. This is a hypothesis comparing 2 population proportions. The P represents a proportion. There's population 1, population 2. I'm not telling you in this particular case what the 2 populations are, all right? There's no verbal information about this, but you do know that the null hypothesis is that the 2 population proportions are equal to each other, which means, I hope you could see that if you subtracted P2 from both sides of this equation, you would get P1 minus P2, this here, equal to 0, right? If you subtract P2 from both sides. And that's why they have a null of 0 down here at the bottom, right in the middle, because that is the null hypothesis. P1 minus P2 is equal to 0. They just happen to put it in this form here. If I had any input into creating this program, I would have suggested to them that they should have just said P1 minus P2 is equal to 0 up here instead of this, because again, some students might get confused by looking at this. Anyway, there is a sample, just like any other thing that we do in inference. There's a sample that we've gathered, and because we're dealing with proportions here, we're going to have 2 population sample proportions that are subtracted, and the subtraction of that sample proportion is put into one of these 2 boxes here. In other words, I showed you in class, right, that it defaults, all of this defaults to certain values. And then if you were creating this hypothesis test, you would take your the sample difference in proportions. It would be in a little box. You'd see what it is, and then you would just simply click one of these 2 boxes here, whichever one it is, because one is negative, one is positive. So whatever number if it's a negative number, you click this one. If it's a positive number, you click this one. And then you just enter the original sample difference in proportions. So what I'm telling you, when I create one of these on a test, is I've already done it. I've entered that number in here. All right, so it's already entered. So what is the next step? Well, I might ask, what is the alternative hypothesis? Remember, a hypothesis test has two hypotheses. What is the alternative hypothesis? Well, P1 minus P2 is equal to 0, which this implies here. I'm clicking off the two-tail box here. That means this is what's called a two-tail test. And a two-tail test occurs when the alternative hypothesis would say P1 minus P2 is not equal to 0. It would be the not equal to sign. All right, so that would be the correct null alternative hypothesis in this case, because this box is clicked, this middle box. If the left tail box was clicked, it would have been P1 minus P2 is less than 0. If the right tail box was clicked, it would have been P1 minus P2 is greater than 0. But in this case, the two-tail box is clicked, so this is a two-tail test. Since I've already entered in one of these two boxes the actual sample data, the sample difference in means is inside here. And all of these dots, what do they represent? These are the computer simulated samples that were created, all right, for the difference in means, the difference in proportions for the two groups. Some of the differences are positive, some of them are negative. If they're positive, means that group 1, since it's P1 minus P2, group 1 has a bigger proportion than group 2. If it's a negative number, that means group 2 is a bigger number, because P1 minus P2 would be negative if P2 is bigger than P1. This is just simple arithmetic, right? Simple arithmetic. Now, these boxes up here, forget about the one in the middle. In hypothesis tests, you can pretty much ignore this one. These two boxes, if in a two-tail test, the sum of these two numbers here represent the p-value.
Excuse me, I really have an emergency. This happened and I called this number and I don't even know if this is legitimate. What am I supposed to do?
I'm going to have to stop for a minute. Hold on. The virus.
Am I supposed to call them?
No, this is a scam. This is one. Don't do anything. No, that is a scam. Don't do it. Reboot it. Turn the computer off and reboot it. Hang on. It's a scam. All right, sorry about that. Anyway, let me just finish this up. There's 2 minutes left before the quiz. Now for a two-tail test, the sum of these two numbers here is the p-value. When you add them up, you compare that to the level of significance, the alpha. If it's less than or equal to alpha, we reject the null hypothesis. If the sum of these two numbers, 0.046 and plus 0.046, 0.092, if that number is greater than alpha, we do not reject the null hypothesis. All right. Now, if you have a one-tail test, either the left tail test or right tail test, if it's a left tail test, you'll only see this box. That is the p-value, and you compare it to alpha. If you have a right tail test, you'll only see this box. That will be the p-value. All right. Any questions about that? Any questions about that? Okay. All right. Now, all of you should turn your videos on so I can see you while you're taking the quiz. Right now, you have your videos off. I hope you were paying attention because I was giving you some really important information. So I'm going to stop sharing. And We have 1 minute. Any questions? Please turn your videos on. There's several people still have your videos off. If you continue with your videos off, I will give you a 0 for the quiz. I have to see you. It's important. Thank you. I hate to actually say that, but you have to have your videos on. All right. So, all right. I'm going to turn the recording off.